say if I take this like this, O here and A here, so OA, so O is a fixed point, and so A here, so OA means the velocity of point A is this V, and this happens to be 30 degree, as you see from the geometry of this equilateral triangle. This is 30 degree. So V has components like this, V cos 30, and this happens to be V sin 30. Okay, and suppose after a certain time the A point has moved here, and there it is, and a certain angle theta, and then velocity, the components remain same basically. So this is V cos 30, and this happens to be V sin 30, and this distance of this OA happens to be R. Now as you know that there minus dr dt happens to be V cos 30, and r d theta dt happens to be V sin 30. So you have to calculate distance covered by particle when it completes one revolution. Okay. So here I can write minus dr by r is equal to minus dr by r d theta is equal to V cos 30 by V sin 30. So that is root 3. So therefore dr by r is equal to minus root 3 times d theta. So there you get from A to R. So this is from 0 to theta. That means I can write here R is equal to A times e to the power minus root 3 theta. So when it goes one revolution, that means theta happens to be equal to 2 pi in one revolution. So therefore R happens to be A e to the power minus 2 pi root 3. So therefore you can find out that's R. So R is A e to the power minus 2 pi root 3. Now from the first equation, this is minus dr dt wala, this equation we can get here, from here minus dr is equal to V, or here it is U, so I have written it as V, no problem. So V root 3 by 2 times dt. So now just put it like this, 0 to t time, and this happens from A to R. So that means that is V root 3 by 2 times t is equal to A minus R. So that means t, the time taken, therefore t is equal to 2 by V root 3 times A minus R times A into 1 minus e to the power minus 2 pi root 3. So this is the required value of time in which it completes one revolution.